Wanted to make, guys, a quick video on how to do some of these inelastic collisions and looking at energy. Most of it, the work's already been done for us since we've already done a lot of stuff with momentum. So let's check one of these out. Let's say in this example right here, we got a 2-kilogram ball and it's thrown at 9 meters per second. And it's thrown at this little cart with a bucket in it or whatever to catch that ball. And that cart has a mass of 1 kilogram and it's just sitting there, let's say. It is at rest. So the ball's thrown into the bucket cart and then the two move off together as one. First question is, what is the velocity? And anytime you have a collision, you're going to solve that with a conservation of momentum problem because you know in all collisions momentum is conserved. If there's no outside forces, and we'll just pretend there's no friction or anything, so we can say there's no outside forces on this system. The system, by the way, is the ball and the cart. So just like we've been doing before, we know that the momentum of the system before is equal to the momentum of the system afterwards. That would be the momentum of object 1 before. I'm going to ignore this thing because it has no momentum, it's at rest, and I'm just going to write the momentum afterwards. I'm not going to write 1 or 2 because I'm just going to consider it one object. So the momentum of object 1 before, I'll consider that the ball. So I'll call that mass 1 times velocity 1. And then afterwards, they're going to have one combined mass. So I'm just going to join them together into one object. And we're going to look for that velocity afterwards. So let's plug in here. The mass of the ball was 2 kilograms. And the velocity of the ball was 9 meters per second. And then afterwards, their combined mass, 1 kilogram plus 2 kilograms, is 3 kilograms. So before we solve this, let's think about it logically. We've picked up mass in a sense. We had 2 kilograms moving before, now we only have 1 kilogram moving. Or excuse me, we had 2 kilograms moving before, now we have 3 kilograms moving. And so there's more mass moving. That means there's got to be less velocity, which just, I think, living in the world, we would have an intuitive sense that it would move slower than the ball when they moved off together. 2 times 9 is 18. And then over here we have a 3. 18 divided by 3 is 6. So we move off with 6 meters per second. One little bit of proportional reasoning I want to put in here to think about too is, if you think about it, in a sense, in the beginning we had 2/3 of our total mass moving, 2 kilograms out of a total of 3. Now we have all the mass moving, all 3 kilograms. So something's got to give. So before we only had 2/3 the mass moving, now we have all the mass moving, so we got to have only 2/3 the velocity. What's 2/3 of 9? 6 meters per second. Shoot, I shouldn't have written this right in the middle. Oh well. Let me come over here in a different color, and let's talk about the energy. This, by the way, is a completely or perfectly or totally inelastic collision. The two objects stuck together. Let's find the kinetic energy of the system before the collision. And that is basically just equal to the kinetic energy of object 1. It was the only thing that's moving. Remember, kinetic energy is 1/2 times mass times velocity squared. So we'll find the kinetic energy of that ball. Its mass is 2. Its initial velocity was 9. Don't forget to square it. 9 squared is 81. This half will cancel out with that 2, and we'll get 81 joules is the total energy of the system before the collision. If you watch the previous video, you will know, since this is completely inelastic, that means that we'll have to have lost energy. So let's find the kinetic energy of the system afterwards. So that's going to be 1/2 times the mass times the velocity afterwards squared. Plugging in for that, be careful here. Our mass is now 3 kilograms is moving, and our velocity we just solved for right here is 6 meters per second. Don't forget to square it. So 6 squared is 36. Doing this in my head, 36 times 1/2 is 18. 18 times 3 is, why could I do that? 18 times 3 will be 30 plus another 24, 54. There we go. So 54 joules is the energy afterwards. So we lost energy. In the beginning, we had 81 joules moving, In the end, we had 54 joules of kinetic energy. Where did the energy go? Well, it went into heat. As the two objects collided, they got hotter. So some of the kinetic energy went into heat. Actually, and this wasn't mentioned in the video you watched first, some of it goes into sound. If you can hear a collision, sound is vibrating air molecules. That's energy. So some of the energy went into sound. And if these objects deformed at all, so we say it went into deformation. So if the ball crumpled or if the cart crumpled, that takes energy to do that. So heat and sound and deformation, that's where some of that energy went.